Hello, Math 201. Welcome to week 3, where we start techniques of differentiation. And today we're going to just continue our shortcuts on ways to calculate derivatives. And we're going to introduce two new rules called the product and quotient rules. And so they'll help us be able to take the derivatives of products of functions and quotients of functions. So recall, what are the derivatives we know, or some of the rules we know so far? Well, we know if we take the derivative of a constant times a function, you can pull the constant out and it's just the derivative times the function, right? And so that's the constant rule. So that allows us to take derivatives of constants times functions. We also know how to take the derivative if you add two functions. If you add two functions together, you just take the derivative of each one separately. So the derivative of f of x plus the derivative of g of x, and that is called the sum rule. But what about if we take the derivative of a product of two functions, f of x times g of x, where this is not a constant anymore, but these are two different functions of x? How do we take that derivative? Well, we could guess maybe it's like the sum rule where you just take the derivative of each and multiply it. And so let's see if that guess works. Let's try it with an example. Let's take the derivative of x cubed times x to the fourth using our guess. So using the guess, this would be the derivative d dx of x to the third plus the derivative d dx of x to the fourth. But the derivative of x and the derivative of x third is 3x squared, and then plus the derivative of x to the fourth, which is 4x cubed. And so that's what we guess the derivative, oh, sorry, not divide, that should be times. Sorry about that, times. And so this should be, our guess is that those should be multiplied. So, and then what would that give us? That would give us 12x to the fifth. But is that actually the right answer? Well, we know that that's actually x to the seventh. And so we know what the derivative of x to the seventh is. It is 7x to the sixth, which is not equal to 12x to the fifth. And so our guess, this guess is wrong. So it's not as simple as just multiplying the derivatives of the functions. We have to do a little bit more. And so to kind of motivate where the actual, and so we're going to show you that the actual product rule, the actual rule will be d dx of f of x times g of x. The actual product rule is going to actually involve f prime of x times g of x plus g prime of x times f of x. So that's the actual product rule. But we will, and let's motivate that first. So where does that come from? In a kind of simple way, or a kind of cute way to think about where this comes from, is thinking about a rectangle. So a rectangle has a width and a length, and the area is the width times the length. But how does the area change as the length or width changes, right? If I change the length a little bit, how much did the area grow by? Or if I change the width a little bit, how much did the area change by? And so the idea is that if we add a little bit of length or add a little bit of width, the amount of area that we added is kind of like the amount that we changed the length by times this little bit of width that we've added. And then the amount that we change the area by when we change the width is this little rectangle right here. It's the change in width times what our fixed length is. And so the change in area is how much is this little green rectangle plus this little purple rectangle. And since we're assuming the change, and so by the way, dw and dl, this means small change in width, small change in L. dA means small change in A. And so the area that we're adding is that green area plus that purple area. And we're going to assume that DL and DW are small enough that this is going to be negligible, that this little rectangle is negligible. And so the amount of area is roughly equal to the change in W times the length plus the change in length times the width. And so bringing that back into kind of calculus terms, that's telling us that the derivative of A is equal to the derivative W times the length plus the derivative of the length times the width. So the change in the area depends on the change in length and the change in width separately. And so if area is length times width, then the derivative of area is the derivative of length times width plus the derivative of width times length. And so the change for a product requires both the change in the two pieces and then the normal parts. And so that's why the product rule is as it is. And so let's record the official product rule. So the official product rule, theorem 3.7 in the book, is if you have two differentiable functions, f of x and g of x, then the derivative of their product is the derivative of the first guy times the regular of the second guy plus the regular of the first guy times the derivative of the second guy. And so that is the product rule. It incorporates both derivatives and both regular parts. So let's do an example. Oops. So here's a function, x cubed plus 2 times a function 2 e to the x, and we're taking their product. And so the way that we can do this is by using the product rule. And so let's record what each individual derivative is. So f prime of x is going to be x cubed, or sorry, is going to be 3x squared. 3x squared. And then what is the derivative of g prime, or the derivative of g? It will be just 2 e to the x. And so by the product rule, this whole derivative will be the derivative of f, which is 3x squared, times the regular of g, 2 e to the x, and then plus g prime of x, which is 2 e to the x, and times the regular of f of x, which is x cubed plus 2. And so just to kind of color code it, that is f of x, there's f prime of x, there's g of x, and then here's g prime of x. Oh, those colors look way too similar. Let me pick a better color. Let's do green. And so that's how the product rule works. And so a lot of your problems will be just kind of calculating that. And so now we're in position to do that. I'm going to skip over this, but I want you to see it. So this product rule is actually legit, that it comes from the definition of the derivative. So you take the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x h. If you take this limit and keep going, you'll actually see that what pops out is you get f prime of x times g of x, and then f of x times g prime of x. And so it does actually work out. There's a clever little trick where you add and subtract something to make it be what you want it to be. But so this is just like kind of adding a 0 to the top to make it flush out, but it does actually work out. And so, but I'm going to skip that because for time's sake. So how about the derivative of a quotient? We talked about products, but what about quotient? And so in particular, what if I want to take the derivative of f of x divided by g of x, so long as g of x is not 0? Well, the way we're going to do this is actually kind of a clever trick. And I'm going to do this fast too to derive it because it's not extremely important, but I do want you to see it. So the idea is we're going to let f of x, we're going to let f of x over g of x, we're going to call that q of x. We're going to just call it this function q of x. And so what does that imply? That implies that f of x is q of x times g of x. And so what we want to find, we want the derivative of f of x, g of x, but that's just q prime of x. So we want q prime of x. That's what we want. And so what we can do is we'll take the derivative of both sides of that equation, because if two functions are equal, then their derivatives are equal, right? Because if you have two graphs are the same, then their slopes or their tangents are always going to be the same. And so two functions being equal implies that the derivatives are equal. Derivatives being equal does not imply functions are equal. And we'll actually talk about that later. But this implication is true, that if you have two functions that are equal, their derivatives are equal. And so we want to use that fact to kind of make q prime of x pop out. And so the idea is take the derivative of both sides, do the product rule on the right-hand side, and you get f prime of x equals q prime of x, g of x plus q of x, g prime of x. And then now we just want to solve for q prime of x. We do some clever algebra, and you get q prime of x equals f prime of x minus q of x, g prime of x over g of x, doing some algebra. And then this is what we want to solve for, but we want it in terms of f of x and g of x. And so I'm going to replace q of x with f of x and g of x. And so you plug it in, and you get that f of x, g of x, the derivative of it, is f prime of x minus f of x over g of x, g prime of x over g of x. But this looks kind of gross, and so I'm going to multiply both top and bottom by g of x. And that gives us f prime of x times g of x minus f of x times g prime of x all over g of x squared. And so this is how we take the derivative of a quotient. And so let's record that. So this is the quotient rule. So as long it's theorem 3.8 in the book, if f of x and g of x are differentiable and g of x is not equal to 0, then the derivative of their quotient is f prime of x times g of x minus f of x times g prime of x all over g of x squared. And so if we rewrote it like this, g of x, if we rewrote the top part as g of x times derivative of f of x minus f of x times derivative of g of x over g of x squared, then the way you can kind of remember this, or how I remember it in my calc class, is we say low d high minus high d low over low squared. That's how I remember the order of this, because the minus sign is important here, right? It's the derivative of it's the low function times derivative of high function minus the high function derivative of low function over low squared. And so that's how this is a cool mnemonic device to remember the quotient rule. So let's put it in practice. Let's try it. So how do we actually do it? So it's low d high minus high d low. So what is the low function? It's 2x plus 3. And then what's the derivative of the high function? It is 2x. And then minus high, x squared minus 1. D low, what's the derivative of the low function? It's just 2. All over low squared, 2x plus 3 squared. And so if this was a written exam, this would be a totally reasonable answer. But a lot of times on the online thing, they want you to simplify it a little bit. So let's just do a little algebra. If you distribute, you get 4x squared plus 6x, and then minus 2x squared, and then that will be plus 2 all over 2x plus 3 squared. So what does that simplify to? It looks like it's going to be 2x squared plus 6x plus 2 all over 2x plus 3 squared. And so that will be the simplified answer. And so that's the quotient rule. It's just plugging it into this formula, taking the derivatives and plugging them in. And so it's not too complicated. Let's do one last kind of example that shows up in the homework and that I kind of really like. And it's the idea of using a table. And so the idea is that we have our x values and then some function values and derivative values. So when x is -1, this is what f of x, g of x, f prime of x, and g prime of x are. And the idea is that we can use the rules, the product rule, and evaluate it without actually knowing what the functions are, as long as we know what the values of them are at certain points. So we know that this is equal to, by the product rule, f prime of x. But because we're evaluating it at 0, we plug in 0. And so it's f prime of 0 times g of 0 plus f of 0 times g prime of 0. G prime of 0, right? Because we know that the derivative, the reason this is because the derivative of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x, right? And so that means if we evaluate it at 0, plugging in 0 means just plug in 0 for all those parts right there. And so that's where that comes from, but I'm just going to erase that because that looks kind of ugly. All right, and so now we just plug in the values. So what is f prime of 0? Well, I go to 0 in this column and I look at the values. F prime of 0 is 1. And so it's going to be 1 times, what is g prime of 0? G prime of 0 is -2 times -2 plus, what is f prime of 0? F prime of 0 is, or sorry, f of 0 is 2 times what is, oh, whoops, this is the wrong one. This should be g of 0, which is not -2, but 2. This should be 2, and then it will be f of 0, which is 2 times g prime of 0, which is -2. And so this will give us 2 minus 4, g equals -2. And so that's what the derivative of the quotient of two functions is, evaluated at x equals 0. because you just do the product rule and then plug in 0 for x. And then plug in the values from that row in the table. All right, let's do one last example. How about this guy where we do a little quotient rule? So this one, let me do just the derivative of the function first without the plugging in. The derivative of f of x over 2g of x, what is that? Well, by the quotient rule, it's low, which is 2g of x, times the derivative of high, which is f prime of x, minus high, f of x, times the derivative of low, which is 2g prime of x, all over low squared, which is 2g of x squared, right? Because the whole low is just 2g of x. The other thing I could have done is I could have pulled out this 2 out the side and just done the product rule and multiplied by 1/2. Either way is fine. It doesn't really matter. And so now if I want to evaluate one, now plug in x equals 1. And what does that give us? That leads us to the following: 2g of 1 times f prime of 1. The reason I plug in x equals 1 is because it says evaluate at x equals 1 right there, by the way, minus f of 1 times 2g prime of 1 all over 4, or maybe I'll just leave it like this. I'll do it as 2g of 1 squared. All right, and now we just plug in the values. I move this over. So what does that equal to? It's 2 times, and if I go to the column with 1, so this, or sorry, row, what is g of 1? G of 1 is 3. So it's 2 times 3 times, what is f prime of 1? -2. And then minus f of 1. F of 1 is -1 times 2 times g prime of 1, which is 1, times 1 all over g of 1. G of 1 is 3. And so this becomes 2 times 3 squared. So what does that equal? This will equal -8. No, -6 times 2 is -12 plus 2 all over 6 squared, which is 36. And so this is -10 over 36. Now we can simplify that. That's -5 over 18. And so that's what the derivative of f of x over 2g of x is, evaluated at x equals 1. And the way we do it is you just take the derivative using the derivative rules we have, and then you plug in the value and then look at the table. And so that is a classic example of something I like to do in exams. All right, that should be all you need. Have a good one.